Every time your phone asks a cloud server something, it's making a round trip that takes time. And some problems can't wait. Picture a self-driving car. It's moving at highway speed, and something steps into the road. It cannot send video to a server in another city, wait for an answer, and then brake. That whole trip might take half a second, and half a second is too long. This is the core problem that edge computing tries to solve. The further your data has to travel to get processed, the longer you wait. And for a growing number of devices, waiting is not an option. So what does edge computing actually mean? Instead of sending raw data all the way to a big remote data center, you process it much closer to where it was created. That nearby location is called the edge. The edge is not one specific place. It could be a small server box mounted inside a factory. It could be a mini computer attached to a cell tower. It could even be a chip built directly into a camera. Here is a concrete example. A smart traffic camera watches an intersection. If it had to send every frame to a distant cloud server to check for accidents, the delay plus the bandwidth cost would be enormous. Instead, a small processor right inside or next to the camera does the analysis locally. The camera only sends a short alert, something like possible collision at grid B4, rather than streaming gigabytes of raw video. That saves bandwidth and gets the message out faster. Latency is the word engineers use for that delay. When data travels from a device to a cloud server and back, you might add anywhere from tens to hundreds of milliseconds depending on how far it goes and how congested the network is. Edge computing cuts that path short. Instead of crossing the country or the ocean, data might only travel a few meters or a few kilometers. The processing happens, the answer comes back, and the whole thing finishes in a fraction of the time. There is also a privacy angle. If a smart speaker processes your voice command on a chip inside the device itself, your words never leave your home. For some people and some regulations, that matters a lot. Edge computing does not replace the cloud. The two work together. Heavy analysis, long-term storage, and training machine learning models still often happen in large data centers. The edge handles the fast, local, time-sensitive work. Think of it like a grocery store. The warehouse far away holds most of the stock, but the shelves right in front of you hold what you need right now. The edge is the shelf. As more devices come online, sensors in farms, monitors in hospitals, cameras in warehouses, the amount of data being generated is growing faster than it is practical to ship all of it to distant servers. Edge computing is partly a practical answer to that math. The location of computation turns out to matter quite a bit. Where a decision gets made affects how fast it happens, how much it costs to transmit, and who gets to see the raw data along the way. If you want to understand what actually runs on those edge devices and how they get updated remotely, that is a genuinely interesting rabbit hole worth exploring.